All right, now let's talk about some of the relationships that we have between gases and different properties of gases. When we're looking at gases, we said that gases are mostly molecules that are really far apart and they have very little interaction with each other. Because of that, all gases tend to behave the same because the molecules aren't touching each other. We talked about intermolecular forces between solids and liquids, but there are almost no intermolecular forces between molecules in the gas state because they're not close enough to each other to even touch. So when we look at gases, one of the things that was noticed very early in development of chemistry is that the pressure of a gas and the volume of a gas are inversely proportional. So this is Boyle's law. Boyle's law mathematically says that the pressure is proportional to the reciprocal of the volume. Now in chemistry, we don't like to use proportionalities, so we could say that the pressure is equal to the reciprocal of the volume times some constant C, and we can arrange this that pressure times volume is equal to some constant C. Well, a lot of times it's difficult to figure out what these constants are, and so we can rearrange this into a two-point form. If I have pressure 1 times volume 1, that's equal to the constant C, and pressure 2 times volume 2 is equal to the constant C. So if they are equal to the same thing, they have to be equal to each other. So this leads us to P1V1 equals P2V2. So we now have a mathematical relationship that has 4 variables in it. If we know any 3 of those variables, we can solve for the 4th. So let's look at an example. What is the pressure if a 1.5 liter sample of methane gas with a pressure of 1,650 millimeters of mercury is allowed to expand to 7 liters? Well, if we look this up, I like to just go through and identify the variables and get the numbers away from the words. So my original pressure is 1,650 millimeters of mercury. My original volume is 1.50 liters. What is the pressure? So my next pressure is unknown and the volume is 7.00 liters. Now, this is pretty straightforward math because you have 4 variables and you just need to rearrange and solve. The biggest problem I usually see with students as they're doing this for the first time is that when they're doing this, sometimes they don't read carefully and they get the wrong pairs of numbers together, and that'll give you a crazy answer. And the key word in reading this is of. 1.5 liters of methane gas has a pressure of the 1650, so those 2 numbers go together. And then it expands to 7 liters, so that has the unknown pressure. Now, when you set these up, we know P1V1 equals P2V2, so P2 is my unknown. I always like to just rearrange the variables before I put any numbers in. I divide both sides by V2. Now I know that when I solve, it'll be P2. Many of my students now who grew up with calculators just like to put the numbers in and do the rearranging in the calculator, and that's fine as well. So when we rearrange, my original pressure, 1650 millimeters of mercury, times my original volume, 1.50 liters, divided by my new volume, 7 liters. So now the liters cancel and I get my answer, 354 millimeters of mercury. So you have to be careful about the units. Make sure you look at it. Make sure that the units you don't want do cancel there. And we can use any units that we want for pressure and volume. So I could have pressure in atmosphere, torr, psi, pascals, anything I want, and the volume can be any volume unit. The only thing you have to worry about is to make sure they are the same unit for both variables. Okay, go ahead and try that next one. Oh no, don't try that one. I'm going to try that one. You're going to do the next one on the next page. Okay, sample of ethane gas has a volume of 125 mils. So my V1 is equal to 125 mils. And 725 force. So P1 is 725 torr. What is the volume? So V2 is my unknown if the pressure, P2, is now 475 torr. And the temperature remains constant. Now, what you'll notice in here is that when we're dealing with Boyle's law, the temperature is always constant, and the sample of gas is always constant. The mass or the number of moles of gas is always constant. So we know P1V1 equals P2V2. Trying to solve for V2. P1V1 over P2 is equal to my new volume V2. So 725 torr times 125 milliliters divided by 475 torr gives me my new volume of 191 mils. So you can solve for either the pressure or the volume. Now go ahead and do the one on the next page. Just do that one at your